Hello friends, in this video today we are going to discuss about Laplace transformation of mathematical physics for BSc and MSc students. And if you are new to my channel, please subscribe this channel and press the bell icon so that you get notified as the new video is uploaded. Okay, so now let us start. Now suppose, what is Laplace transformation? Here you see, suppose we have a function of t, f of t. So by Laplace transformation, symbol is this L, it will be transformed to new function capital F, function of s. Okay, and this is equal to nothing but integration 0 to infinity e to the power minus st f of t dt. Right, so this is the Laplace transformation, the definition of Laplace transformation. So here this f of t is a function, defined for all positive values of t. Positive values of t, right? And this Laplace transformation transform this function, which is a function of t, to a new function capital F, which is a function of s, right? So by this transformation we can solve differential equations, okay, without finding the general solution and arbitrary constants. So we can solve differential equations. But before we learn how to solve differential equation using this transformation, we will discuss the basics, formulae and theorems on this Laplace transformation. Okay, so and also we need to learn inverse Laplace transformation also. After knowing all the basics informations and formula, theorems, all that, then we can solve the differential equation using this transformation. Okay, so we will discuss how to solve differential equation using this transformation later. First, in this video we are going to discuss about we are going to learn the basics formulae of Laplace transformation and their proof as well. Okay, fine. Laplace transformation of 1. Laplace transformation of 1 is 1 by s. This is our first formula. Laplace transformation. Laplace transformation of 1 is 1 by s. Now let me show you the proof. So now here you see Laplace transformation of 1 according to this formula. Laplace transformation of f of t is equal to this one. So Laplace transformation of 1, here we will get 0 to infinity e to the power minus st, and here this f of t is 1. This is f of t, right? So now according to this formula, instead of f of t, here we need to write 1 then dt, right? So that means simply you can write integration 0 to infinity e to the power minus st dt. That's what you can write. Now if you integrate this, then what you will get? Integration of e to the power minus st, that's gonna be minus 1 by s e to the power minus st, right? And our limit is from 0 to infinity, because you see, we know integration of e power ax dx is given by 1 by a e to the power ax, right? So we have applied that formula to integrate this. Okay, so hope you have understood this. Now let me clean this first. Here you see if you put this limits here, first if you put upper limit here, that's gonna be infinity, e to the power minus infinity, right? And e to the power minus infinity, that becomes 0, then plus sorry, not plus, then upper limit, then minus, if you put 0 here, if you put t is equal to 0, then s into 0, that's going to be e to the power 0, and e to the power 0, and we know anything to the power 0 is 1, so that's why here we will get minus 1 by s into 1, right? That is so this result become 0, here it is minus minus, so it's become plus 1 by s. So that is why Laplace transformation of 1 is equal to 1 by s. That's how we can prove, right? So what is our next formula? So let me clean this first. Now Laplace transformation of t to the power n is equal to factorial n divided by s to the power n plus 1. So let me prove this. Here n is equal to 0, 1, 2 and so on. So now let us prove this. Now here you see Laplace transformation of t to the power n, and according to this formula, integration 0 to infinity e to the power minus st f of t, here f of t is t to the power n, so t to the power n dt, that's what we have got. This is suppose equation number 1. Now let us put st is equal to x, suppose, okay, so that t is equal to x by s, right? Now here you see, if you differentiate both sides with respect to t, then what you will get? You will get s dx by dt, then dt is equal to, dt will be 1 by s into dx, that's what you will get, okay? So if you substitute those values here in 1, then this equation number 1 will imply that Laplace transformation of t to the power n is equal to 0 to infinity e to the power, so st is replaced by x e to the power minus x, then t is replaced by x by s, this is t, isn't it? So here this t is replaced by this, and as we have t to the power n here, so we have to write x by s whole to the power n, then dx by s, right? So because dt is dx by 1 by s dx, that means dx by s. So here you see, or you can write this way, this s can be written outside, 1 by s. That's how you can write if you want, okay? Or so let me keep it this here, let me write the s here now for the meantime. So now you see, from this term we have got x to the power n into 1 by s to the power n, right? And dx by s means we have 1 by s dx, so 1 by s into 1 by s to the power n, that's gonna be, this two gives 1 by s to the power n plus 1, and this 1 by s to the power n can be written outside the integration. So now, so let me clean this first. So what we get here, so 1 by s to the power n plus 1 integration 0 to infinity e to the power minus x to the power n dx, that's what we have got. So hope you have understood this. Now remember one thing, remember this result, remember this one as formula. This, let me use another ink here. this integration 0 to infinity e to the power minus x dot x to the power n dx is equal to factorial n. Remember this one as a formula, right? This is equal to factorial n. So that's why we can write, let me clean. So that's why we can write that 1 by s to the power n plus 1 into factorial n, or you can write factorial n by s to the power n plus 1. So that's how we can prove. So hope you have understood. Now let's move on to the next formula, formula number 3. Let me clean this first. Now third formula is Laplace transformation of e to the power at, and that is equal to 1 by s minus a. So here remember one thing, s is greater than a. So let us prove it. Let us prove this formula. Now by definition, Laplace transformation of e to the power at, that's going to be equal to integration 0 to infinity e to the power minus st, and here function of t is e to the power at dt, right? Now here if you multiply this to e to the power minus st and e to the power at, then it must give e to the power minus st plus at, right, dt. Then let us take minus t as common. Then what you will get, 0 to infinity e to the power minus s minus a into t dt. That's what you will get. Now let us integrate this. So if you integrate, we know integration of e to the power ax dx is given by 1 by a e to the power ax, right? So if you apply that formula here, then what you will get, let me clean this first. Then what you will get, here you will get minus 1 by s minus a, then e to the power minus s minus a into t, and limit 0 to infinity, right, from 0 to infinity. So let us put the upper limit and lower limit instead of t. So if you put here infinity instead of t, if you put infinity, then what you will get, you will get e to the power minus s minus a into infinity into this, that's gonna be again infinity, and e to the power minus infinity is nothing but 0, right? Then if you put 0 here, if you put e to the power minus s minus a instead of t, if you put 0, then it's become e to the power 0, and e to the power 0 is nothing but, anything to the power 0 is nothing but 1, right? So what we have got here, let me clean this first, just to, after putting this upper and lower limits here, we have got, so this is our next line, Laplace transformation of e to the power at, that's going to be equal to minus 1 by s minus a into 0 minus 1. That's what we have got after putting the upper and lower limits. So that's going to be equal to, so here 0 minus 1 is minus 1, so minus 1 into this minus, that's going to be plus 1 by s minus a. So this is Laplace transformation of e to the power at, right? That's how we can prove. So hope you have understood this. Now next formula, what is the next formula? Let me clean this first. So this is our formula number 4, Laplace transformation of cos hyperbolic at, that's s by s square minus a square. So remember one thing, remember this one as formula, that cos hyperbolic at is equal to e to the power at plus e to the power minus at by 2. And also remember, if you have sine hyperbolic at, then it's gonna give you e to the power at minus e to the power at by 2. Okay, remember both. These two are important formula, so remember these two. So now what we're going to do here, let me prove this. How to prove this? Okay, so proof. Laplace transformation of cos hyperbolic at. So here you see, we can replace cos hyperbolic at by this result, right? So let us do that. Laplace transformation of, instead of cos hyperbolic at, so what we can write? We can write e to the power at plus e to the power minus at divided by 2. That's what we can write. So remember one thing. If you have, suppose, Laplace transformation f of 1, f1 t plus f2 t, then you can write in this manner, that Laplace transformation of f of 1, f1 t plus Laplace transformation of f2 of t. So you can write this way. So similarly here also, what we can do, let me clean this first. So we can write this is equal to, you can write the half outside, okay? Then Laplace transformation of e to the power at plus Laplace transformation of e to the power minus at. So now here you see, we have already got this formula, that Laplace transformation of e to the power at is nothing but 1 by s minus a, okay? So if you have Laplace transformation of e to the power minus at, then what you will get? Just e to the power s plus at. Now, okay, that's what we will get. Now let us apply these two values. Let us put these two values here. Here. Then what you will get? 1 by 2. You will get 1 by s minus a plus 1 by s plus a. So this is already known to us. So 1 by 2. So if you, let us take LCM here. So s minus a into s plus a, then s plus a plus s minus a. So here minus a plus a gone. So what we have got here, 1 by 2, s plus s twice s, and here a minus b into a plus b formula you can apply here, that is a square minus b square. In this case we will get s square minus a square, isn't it? Because s minus a and s plus a, we have s minus a and s plus a. If you multiply these two, that must give this, right? So here these two cancels. So what is the final result? S by s square minus a square. That's what we have got. So that's how we can prove. So hope you have understood. Now let's move on to next formula. So this is our fifth formula. Here Laplace transformation of sine hyperbolic at. So what was the Laplace transformation of cos hyperbolic at? That was s by s square minus a square. So here only different is this s becomes a here in this case. Remember these two, okay? Now let me show you how to prove this. So Laplace transformation of sine hyperbolic at. So let us apply this formula. Sine hyperbolic at is this. Let us put this result. If you put this result, then what you will get? Laplace transformation of e to the power at minus e to the power minus at, right? Divided by 2. That's what you will get. So we can write Laplace transformation of sine hyperbolic at, that's equal to half Laplace transformation of e to the power at minus Laplace transformation of e to the power minus at. So we have already got that Laplace transformation of e to the power at is nothing but 1 by s minus a. So e to the power minus at. Laplace transformation of e to the power minus at, that's going to be 1 by s plus a, right? So let us use these two results here. Then what you will get, putting those two results, 1 by 2 here, 1 by s minus a minus 1 by s plus a. Now let us take LCM and let us simplify. Then s minus a into s plus a, and s plus a minus s minus minus plus a. That's what you will get, right? So from here you can see these two minus s plus s cancel. So what we have got here, a plus a twice a, that's why half twice a by s square minus a square. Product of these two is s square minus a square. So here these two cancels, and so our final result is what we have got, a by s square minus a square. That's what we will get. That's how we can prove. So this is the fifth formula, right? Proved. Okay, so what will be the next formula? So our next formula is, let me scroll down the page. So sixth. So next formula is Laplace transformation of cos at, not hyperbolic, only cos at. Okay, so cos at is equal to s by a square. Let me write s by s square plus a square. So remember one more thing. If you know this formula, then you can remember this. Let me write it properly. S by s square plus a square. So if you know this formula, you can remember one more thing, that 7 Laplace transformation of sine at. So it's very simple. Now that's gonna be a by s square plus a square. So here only the numerator is different, just replace the s by a. Okay, so that's how we can remember these two formulas. So now here you see, let me prove these two one by one. So first let us prove this number 6, this one, Laplace transformation of cos at. So how to prove this? Cos at. So cos at. So cos at, remember this one as a formula, e to the power iat plus e to the power minus iat divided by 2. Remember this one as formula. So if you use this formula here, then Laplace transformation of e to the power iat plus e to the power minus iat divided by 2. Then what you can write here, 1 by 2 Laplace transformation of e to the power at plus Laplace transformation of e to the power minus iat. That's what you will get, right? So we know that Laplace transformation of e to the power at is nothing but 1 by s minus a, right? So Laplace transformation of e to the power iat will be 1 by s minus ia, right? Similarly, Laplace transformation of e to the power minus iat, that's going to be 1 by s plus ia, right? So let us use those results here. 1 by 2, using these results, what we will get? We will get 1 by s minus ia and plus 1 by s plus ia. So now let us take LCM and simplify these two. So half, that's what we will get here. S minus a, sorry, not a, only a, ia into s plus ia, s plus ia plus s minus ia. So that's what we will get. Now cancelling this positive and negative IA, so what we have got, first let me clean this first portion. So let me clean this portion, right? So here you see, now I'll continue here. So this is the next step from here. Okay, so half you will get twice s, and if you multiply these two, you should get s square minus ia whole square, and I square is -1. So that's why what you're gonna have, so you're gonna have s square plus a square, right? So here two cancels, so our final result is s by s square plus a square. So that's how we can prove. So this number 6, formula number 6 is proved. Now let us prove this 7. So let me scroll down the page. So what was the 7th formula? That was Laplace transformation of sin 80, which is nothing but a by s square plus a square. So let us prove this. So remember, sin 80, that's gonna be e to the power iat minus e to the power minus iat divided by 2. Okay, remember this as a formula, right? Not only twice I. Remember these things. Okay, so now here you see, if you use this result, then what you will get. So Laplace transformation of sin AT can be replaced by this value, then what you will get, e to the power iat minus e to the power iat divided by twice I. That's what you will get. Okay, now 1 by twice I can be written outside as their constant, that is constant. So Laplace transformation of e to the power iat minus Laplace transformation of e to the power minus iat. I have already told you what are the results of Laplace transformation of these two, e to the power iat and minus iat. So minus iat, let me write it cleanly. So let us use those results, then what you will get, Laplace transformation of this is 1 by s minus ia, then plus, sorry, we have minus here, so 1 by s plus ia. So again, let us take LCM and simplify. Sin 1 by 1 sin minus ia into, sorry, not sin, s minus ia, then s plus ia, then after LCM, s plus ia minus s minus plus ia. That's what you will get, right? So now here minus s plus has gone. If you multiply this to what you will get, you know that. So it's very simple. I don't think I have to explain it again. So here on the other side, let me continue on this side. So then what you will get, half, sorry, not half, 1 by twice I, so into here ia, that's going to be twice ia by s square plus a square. So here twice I cancel, so what we have got, simply a by s square plus a square. So that's how this formula is proved. So this is the formula number 7, right? So these are the basics formula till now we have proved. Okay, and we have to discuss some properties and theorems of Laplace transformation, and those things we will do in the next video. Okay, I don't want to make this video too long, so hope you have understood these things. And if you like this video, please hit the thumbs up button and share it with your friends. And if you're new to my channel, please subscribe this channel and help me to grow and inspire me to create new contents for you. Thank you for watching. See you in the next video.